Good afternoon, everyone, and welcome to the INGenIOuS panel on documentation and dissemination. Today's panel theme lead is Dr. Claudia Neuhauser, and I'll be turning it over to her in just a second to introduce herself, her topic, and her panelists. I'd like to tell you a little bit about the INGenIOuS project first. You can find it on ingeniusmathstat.org. There are 6 online panels that are taking place, followed by a capstone workshop in July. It is supported by the community at large and the professional societies in the mathematics and statistical sciences. With no further ado, let's begin today's panel. Thank you for joining us. Claudia.
Thanks, Thomas. I'd like to welcome everybody as well to this panel. We have 2 other panelists here. We have Laura Kvatko and Gavin LaRose, and they will introduce themselves in more detail a little bit later. Let me start first with saying a little bit about this panel. So it's about documentation and dissemination, and what we want to do in the next hour is talk mostly about the issues related to documentation and dissemination and mention some of the resources. And as the other panel, the scope of this panel is really focused on mathematical sciences education at both the undergraduate and graduate level. This will probably naturally also address some of the lower division courses which are taken by many other students, as you all know, but the main focus is really on the students who are in the mathematical science. What we'll do is we'll start out with giving a brief introduction of each of us with a little bit of background, and then we'll get back together and talk about the various issues. So we start out with this poster of my slides, and then we'll follow up with Laura and then Gavin. So we'll be in a few minutes, just one of us. Okay. Okay, so as I said, I'm Claudia Neuhauser. I'm at the University of Minnesota Rochester, which is a new campus of the University of Minnesota. And I'm Vice Chancellor at the campus and also Director of Graduate Studies of the Biomedical Informatics and Computational Biology program. So I have a PhD in math, and most of my research is pretty advanced for diagnostic markers in complex diseases. And prior to that, I worked primarily in spatial ecology and population genetics, so on the very applied side of mathematics. I've taught a fair amount of calculus, both sort of more traditional calculus that's offered for engineering students, and then I developed a calculus course for biology students, and out of that grew a modeling course that's really more sort of data-driven. And then my area is probability and statistics, so I've also taught in those 2 areas. And currently most of my teaching is in bioinformatics and computational biology graduate programs. I teach the first 2 courses in bioinformatics. In this graduate course, so we use a lot of the online courses now to fill gaps, like other MOOCs courses that are offered through edX, iTunes U, and so on. So I've also quite a bit of experience in exploring those courses. So as I mentioned just before, I've done quite a bit of curriculum development. So I wrote a textbook, Calculus for Biology and Medicine, which is now in its 3rd edition, and that's more sort of a traditional approach to teaching calculus. And then over several years, I've been involved with BioQuest, which is a curriculum consortium, and I started the Numbers Count website and program, which was supported by the Howard Hughes Medical Institute. And so through that, I've developed additional course materials, primarily in statistics and the modeling aspects of calculus, and we also run a lot of workshops. And I've developed short modules for science courses. So the web page is through BioQuest. So if you want to log into that, if you Google BioQuest, you get to that website, and then just Numbers Count. And so the workshop materials are also standalone modules that people can use for teaching. And so to disseminate the materials we've developed through Numbers Count is essentially, I have a website where all the materials are freely available. So workshops we go to community colleges, so instead of asking people to come to us, we go to them, and then there's typically a group of faculty from the sciences and mathematics, and we teach all modules there. And then I participate in BioQuest's annual workshop. We also run some, typically one workshop, and the materials are also on my website. Most of what I do now is I focus on the data and exploration side of data, and then bring the theory in through the data exploration. So all the materials we developed are freely available, and everybody can download them and use them as they see fit. And the purpose of those workshops is sort of integrating math and statistics into the biology courses, and primarily into the lower division courses, even though some of the topics we cover are more advanced, like principal component analysis, data exploration, linear regression is quite often covered, hypothesis testing. So the approach I've chosen there is sort of opposite what one typically does in a more advanced math course. I start with the application, and then through computation, students explore the theory. And we use Excel a lot because that's very accessible to students, and there's instant reward as well. When you graph something, you can see it right away, and students like that quite a bit. I've always also been involved in assessment. This is a focus of the programs we have built here at the University of Minnesota Rochester. The undergraduate program we have in the Bachelor of Science and Health Sciences, the faculty are working on developing how to assess the different courses, and it's part of their tenure code to do this. And so we've started to do quite a bit on that one. And prior to this, I was PI on an IGRIC. And so this is some of the lessons I learned. We developed assessment tools. We tried to disseminate them. We actually had a website for the graduate school, but then changes happen at universities and websites disappear. So this was sort of a short-lived effort, which is no longer accessible to people. And since I don't have the grant anymore, the assessment tools are also not available anymore. And I think that was the last slide I wanted to show, so I'm going to end my slide share, and I'm going to hand it over to Laura, so you can introduce yourself.
Okay. Welcome, everybody. Let me just take a minute here to bring my slides up. Okay, hopefully everybody can see the slides now. So I want to just start by giving a brief introduction to myself and to my interest in documentation and dissemination. My academic appointments, I'm an associate professor with a joint appointment in statistics where I'm 80% and evolution, ecology, and organismal biology where I'm 20% at Ohio State University. I'll also, I guess, effective tomorrow, become an associate director at the Mathematical Biosciences Institute here at OSU, and that is one of the NSF-funded math institutes. I've also, for the past year, served on the board of advisors for NIMBUS, again, an NSF-funded institute that gets at the interaction between mathematics and biology. I also serve as the chair of the interdisciplinary PhD program in biostatistics here at OSU, and that's a joint program between the Department of Statistics and the Division of Biostatistics that sits within the College of Public Health. My research interests are in statistical phylogenetics and more general problems in statistical genetics, and I also have an interest in interdisciplinary education. As you can tell from my academic interests, I work in the area of mathematical biology, and so I have an interest in how we educate students and prepare them for careers in interdisciplinary areas such as mathematical biology. So I don't have a lot of background, I guess, is what I want to say, in documentation and dissemination, but it really impacts my activities both in research and teaching. So I thought I'd give some examples of this. When I came to OSU 6 years ago, one thing that I was supposed to do was develop a course in statistics for the life sciences, and we're sort of starting from scratch. It was supposed to be a calculus-based course, an introduction to statistics for undergraduates who were majoring in life sciences. And I started looking around and realized, well, there's lots of choices to make, and I have trouble evaluating all the choices, what textbook to use, what software to use, what things to develop. And so spent some time on this. I've talked about it before in a cause webinar, so the link is there, and there's some links there to some articles that we've written about the curriculum in mathematical biology for undergraduate students here at OSU. So I thought I'd put the link up if anyone's interested in taking a look at that. More recently, as I've been working at the MBI since I've been here at OSU, I've become very interested in how we develop educational resources to have a very broad impact and to train people in mathematical biology. So, so my role there as I begin as Associate Director is going to be to try to utilize the MBI resources and develop new resources to really maximize educational impact. So we have things in mind such as when the MBI puts on a workshop, so they have themes associated with the academic year and various workshops built around those themes. So one thing we'd like to do is to develop online tutorials that people can view before they attend the workshop. So if we have biologists who want to attend and who are worried that they may not have the right math background, or mathematicians who want to attend but don't have the experience in the biological side of things, they could watch the tutorials before they come at their own pace, get up to speed, and then really take advantage of the workshop in the best way possible. So that's one thing that we're working toward. Another initiative that we have is a proposal that we're putting together for the NSF RTG program. We call it SAMBA, which is Statistics and Mathematics in Biological Applications. And there we're going to work on providing online training modules, various topics at both the undergraduate and the graduate levels. So these are two areas where I'm interested in trying to see what's out there, see how we can do the best job possible with these things, and then how much has been documented and how can we best document our efforts. So I thought I'd briefly mention some existing resources for documentation and dissemination from the statistics community. And there's one very nice resource that I think would be great for people to take a look at. This is CAUSE. CAUSE is the Consortium for the Advancement of Undergraduate Statistics Education. And I have the quote there from the website. It's a national organization whose mission is to support and advance undergraduate statistics education in 4 areas: resources, professional development, outreach, and research. So they have a very nice website, which you can take a look at, and hopefully that's on your screen right now. There's annual workshops. For example, right in the center you see USCOTS, the U.S. Conference on the Teaching of Statistics, that just recently took place in May. There are tabs for research, goal of the research component of CAUSE, lots of resources there, the same sorts of things. Professional development, the resources tab is very nice, lots of information that you can get here, lecture examples, lab examples, projects, homework, cartoons even. Some of the cartoons are really great, so it's sort of fun to take a look at those. There are webinars. I think these are held every couple of weeks, and they're archived, so you can watch the previously recorded webinars as well. So this is a really wonderful resource for teaching statistics at the undergraduate level. Lots of information here, and a really nice way to look at things. The other thing I thought I might comment on before I turn it over to Gavin is just some things about the role of the math institutes in documentation and dissemination. And I've mentioned some of this briefly, but I'll say a little bit more. My association is with the Mathematical Biosciences Institute here at OSU, and we have a lot of educational initiatives. For example, there are annual undergraduate and graduate summer programs. The graduate summer program is co-sponsored with CAMBAM and Nimbus. Throughout the academic year, there are MBI courses, and I have again the link there if you want to look at some of the courses. These are usually taught by faculty members that are visiting the MBI, and so you get a wide diversity of topics. Again, these are all recorded, so it's possible to watch past MBI courses in the video archive. There's a workshop for young researchers in mathematical biology that's held annually, as well as an upcoming workshop teaching discrete and algebraic mathematical biology to undergraduates. So lots of existing educational opportunities at the MBI. There are also these new educational initiatives. As I mentioned, we'll work toward developing online tutorials prior to workshops, and we're working on developing online training modules at graduate and undergraduate levels. One thing I didn't mention before is the MBI Graduate Lecture Series. This is an edited volume that gives curriculum materials for that can be used in 2-week modules to train people in mathematical biology. I want to say a little bit more about the proposal we're preparing for online training in mathematical biology, because this is really where I've run into the need for more documentation and better dissemination of previous efforts. So what we're planning is to develop these online modules at both the undergrad and the graduate levels, and each module will have a a sequence of short segments that have sort of a lecture-style presentation, and they're all built around some overall topic. At the end of each segment, there'll be interactive exercises so that participants can test their mastery of the material as they work through it. So these will be little questions online. You can get hints. You can see the solution ultimately if the person is not able to solve the problem. If they get enough hints, finally it will solve it for them. And so that's supposed to help people, keep up to speed as they work through the material. We'll also have suggested supplemental readings, access to online office hours. When we run modules during academic terms, we'll have some regular office hours where people can check in and chat with some people who are knowledgeable about the topics. And then we want to come up with a way to provide for more formal assessment following completion of a set of modules. So how do we plan to do this? Well, the first step is to build these modules around MBI's existing video archive. So they have a very large video archive already recorded. It's not difficult to download and watch the videos. So what we're going to do is we're going to take that resource and just build everything around it, build the short segments, build the exercises, and then really make them nice self-contained modules. Once we have experience with that, we'll seek out local faculty with local expertise and ask them to produce some modules, and then finally we'll work on building modules around the MBI theme areas for each semester, so that we really are presenting high-level mathematics, current topics in mathematical biology in this online format. So what's our progress to date? We're still largely planning these things. We've built one small module as an example to become familiar with what issues are involved, and here are some of the challenges. What's the best format? How long should a typical clip be? What type of exercises should we have? How much of the slides of the speaker do you display versus the speaker themselves? The need for incentives. Once students decide they want to enroll in one of these online modules, how do we get them to stick with it and continue to participate and finally complete things? How do we give credit when someone does complete a module? How do we assemble modules into courses? And then how do we disseminate? How do we get the word out about what we've done and really take these modules so that they can be used by lots of people in different places for different things? So those are some of the things that we've been talking about. We also think this has a nice opportunity because we can sort of study, if we get people to take these modules, we can sort of study how they do and what things work best and sort of vary some of the components of the modules and see how that affects their sort of completion and their knowledge from the modules. So we're pretty excited about this effort, but definitely it impacts these ideas of documenting and disseminating efforts and how can we learn from what others have done in the past. So I have some more slides about issues and challenges, but I think I'll save those if we'd like to discuss them later and turn things over to Gavin.
All right. So
let me turn mine off here.
There we go.
Okay.
Look at that. Okay, so in that case,
Okay, I think we just lost Gavin.
okay, take two. Take two. Am I back here?
Yeah, you're back.
It just knocked me out, but I think I'm back. Is that good? All right. So it seems to suggest that I'm here. So I'm going to continue assuming that that's true. Excellent. So I'm Gavin LaRose, and I am at the University of Michigan. And my position here is actually an odd one. I'm a split appointment between a lecturer, so non-tenure track teaching faculty largely, and I'm also the person who's in charge of all of the instructional technology that we actually use in the math department here. My background is in applied mathematics. I say very applied in that it's almost engineering. And then after getting my degree, I actually taught for 6 years at a small liberal arts college at Nebraska Wesleyan. And then starting in 2000, I took over some incarnation of the position that I currently have now in the Department of Mathematics. And then the two other pieces of my background, which have, I think, relevance for the consideration of documentation and dissemination of teaching projects, are that I was a member of the Project leadership team from 1997 to 2012, and I've also worked on WebWork, which is an online homework system. And I'll talk about both of those in just a second. I wanted to start, though, by giving a little background about my connections with dissemination and documentation. Certainly, in my own teaching, I've had the opportunities to take advantage of what other people have disseminated. And in most cases, the ways that I've gotten information from this have been through formal and informal networks. Project Next has been certainly a large part of that, but conferences and workshops also play in. And these all have the sort of the three areas that I found that these have contributed most greatly to my teaching are in using inquiry-based methods in teaching and writing projects and computer lab exercises. And we could talk about those more if we need to. But I'm also connected with these two formal projects, Project Next and with WebWork, which at least either in an informal or a sort of ancillary manner or a direct manner are concerned about dissemination. And so I want to talk about those next. So Project Next is a professional development program with the MAA. It's for newer recent PhDs in the math sciences, and so that means that all of the participants are within 2 years of their PhD. So they're in their first or second, that's not true. They're in the first or second year of full-time teaching post-PhD. So if they had a research postdoc, they could actually still be participating. It's been in existence since 1994, and there are a total of 1,400 fellows at this point, and another, about 80 fellows will be added as of tomorrow when the application process is finished for this year. It includes a 1.5-day workshop before the summer MAA meeting, panel sessions at the joint math meetings, and then a second workshop the following summer. And one of the significant aspects of these workshops is that they include a bunch of breakout sessions and short courses. And so these are ways that we communicate with the fellows about issues in teaching and learning in mathematics and developing an academic career. And so these are usually on parts of the teaching process that they're going to be engaged in, but also things like advising and getting students involved in undergraduate research and so on. Therefore, because of this nature, the workshop nature, Project Next provides exposure to some, I said 15 to 20 teaching and learning projects to 75 to 85 new faculty per year, which is a slight overstatement because not all of the fellows participate in each of the presentations, but it's probably not too far off. It is, in some sense, a unique or an odd environment because the participants are very engaged and very active. They're self-selected by dint of having applied to be fellows, but they're selected by the Project Next team and therefore are pretty good people. And the presenters are handpicked to be engaged and effective. And anecdotally, we have pretty good adoption of ideas from these presentations. But I think a large part of that is that Project Next is a very focused project. It has a very well-defined group of people who are participating, and the presenters have very strong and very carefully phrased instructions on how to communicate with them about communicating practical application and how to take the ideas that they're presenting and use them in the fellows' classrooms. And the strong presenters are the norm. We usually get very, very good people there. WebWork, of course, is an open source online homework system. It can be used for free for a year through the MAA if you don't have too many students, and after that there's a nominal fee for it. It's used by over 450 institutions, and according to one study, a majority of students using online math homework at doctoral departments in the country. And it includes a library, which used to be called the National Problem Library, and now is called the WebWork Open Problem Library, which has a large number of problems from a large number of textbooks. And so WebWork is necessarily concerned with dissemination because it's trying to get itself out. It has the desirable characteristic of being essentially unique in the pantheon of web homework systems in that it is open source and it is free if you can host it yourself. I think the largest web homework system by user base is actually my math lab because it has a very strong representation in the pre-calculus and algebra areas. WebAssign is, of course, very well known. And then WebWork is sort of the third that people have usually heard of these three. It's open source, generally widely distributed, and has, I think, a strong dissemination largely because of its being visible to a very large extent, and also that it is sort of essentially a unique tool, and it also does more or less everything that you need to be done in a web homework system. And so that is my preliminary background, and so I'm going to try and turn off my screen share here and come back and turn it back over to Claudia to continue the discussion.
Okay, thanks, Lauren, Gavin. So we've heard quite a bit now about the different types of materials that are available, and sort of looking at the way that mathematics teaching happens. I mean, much of it is still sort of more the traditional recitation format where people use traditional textbooks. But on the other hand, there's really a lot of material out there, and so I think what we may want to talk first about is how well does this actually work, the sharing? I mean, Gavin mentioned that the adoption rate from Project Next, what people learn, is very high, and there's WebWorks and all the other different tools. why don't we just talk first about what are the challenges and maybe getting more people to adopt it, and how well it currently works the way we share our materials. You want to sort of follow up on this, Gavin?
Sure, I would be delighted to start off on this. I think that there's sort of three fundamental issues that come with this type of communication. One is that you have to reach the right people, so the people that actually want to hear about what you're trying to disseminate information on. It has to be communicated in a manner that they can take what you're saying and try and use it. And then ideally what you're communicating has to be portable enough that they don't have to spend hours on end redeveloping it so that it'll actually work in their own classroom. And so I think that something like Project Next has an advantage that it's is as well focused as it is, that we know who the people that we're talking to are, we know where they are in their careers, we know sort of that they're interested in the subject because they're picking to participate both in Project Next but also in the workshops that there are different breakout sessions that they're doing. And then the presenters are told very carefully how to communicate and what they need to say in order to get the fellows engaged. But this is, I think, sort of unique to the case where you've got a small workshop and you have people that you know and you have presenters you can control reasonably well. And some of the difficulty, I think, with dissemination is that the scale of the community that we're trying to reach now is incredibly big. If I were trying to reach the faculty at the University of Michigan, then I have to communicate with approximately 120 math faculty about something, and they have a common understanding of the problems that they face because they're all teaching in the same university. If we go just to the Big Ten, then we've got way more faculty to communicate with in a whole bunch of different environments. And then if we start talking about national or international dissemination, I think the problem really becomes one of getting the right materials to the right people in the right way.
Right, I agree. It's a substantial problem. I think from the viewpoint of someone who's just sort of looking at what's out there and trying to decide what to do, I think one of the big obstacles is that maybe you look around and you see, well, this looks good, and this looks good, and this looks good, and they all sort of look interesting, and you have a limited amount of time to try to figure out which thing to invest your time in, and it just becomes very hard to sort of compare them and decide, well, I'm going to spend the next so many hours investigating this, and well, my time's up, so I either like that and I'll adopt it, or I don't, and I don't have a chance. So it's very difficult, I think, to sort of compare things and see, how to spend your time for lots of us that have so many demands on time. So it's really the appealing thing I think about Project Next, although I'm not very familiar with it, is that you have people sort of in a room and there's some presentations and some discussion, and that's when you can learn things quickly, when you're talking with others. But if you're just sort of looking at what's out there and trying to decide what to do, I think it's very difficult. So I really like the idea of things like the webinar, where you can be talking to people sort of face to face, but without having to travel anywhere, and seminars and some things that you can do online. The interaction works better for me personally.
We could probably add something too, if I may just jump in quickly. The advantage of a workshop or a presentation that one goes in and has somebody who's selected a presenter is that you don't have to do some of the filtering, right? So if you go to a workshop on teaching something and they've said, here is a really good way to do it, then you sort of don't have to spend the time initially trying to figure out what it is.
Right.
Both of you sort of mentioned the portability, and then Laura mentioned how difficult it is to look through all these materials. I mean, I think we've all been through this. We would like to add some authentic experience or some good data to this, and you look and look and look, and there's only so many hours in the day to really do this. Give any suggestions on what we perhaps should do to make that piece easier for people when you look through this, that you don't have to spend hours to figure out whether this even fits into your classroom.
So sorry, was that a question of how to accomplish that?
Yeah, so ideas of, especially you're looking now at developing all these materials, and I think people are going to have the same problem. They will look through this, and are there ways that you're thinking about that we could tag it, or other possibilities to make that easier for people to select the material?
It'd be really nice to have a resource where people could share their experiences using the materials, and just in a very informal way, almost the way people comment after a blog or something online. If someone said, hey, I used this for this course and it worked great for these reasons, and here were the challenges, and then if you want to contact me, here's my email address. Stuff like that might work really well. I don't know. I mean, then you have the problem of having to read everybody's comments and decide how to value each of them. So that's problematic too. But you start, if enough people comment on things, you start to get a consensus of, here's what was good about this, here's what was bad about this. So I don't know, a resource like that might be something I would sort of sit and page through a little bit and try to see if there's consensus about materials.
I think also, Claudia, you've actually done a very nice job of connecting this question of documentation with that of dissemination, right? That if something is widely disseminated but there's no information about what it actually is or what it requires, it's much more difficult to figure out how to then use it. And some of this whole problem is getting a set of documentation or getting the pieces out there so that people can see them, so that it's clear what it is that's there and how one might use it. And some of that can be accomplished, I think, by Laura's idea of comments, and some of it may just be that we have to get better at figuring out a format or a structure in which to present these things, so that when people come looking, they are able to figure out what's going on.
I mean, some of it is also a bit more personal. Like, I may like a resource that you may not like. And what I would always wish is I try out a certain resource, I like it, somehow I put it in that I like it, and then the system suggests to me, well, people who like it
Nice.
also like this, the way we works now. Do you ever foresee that something like this would even be possible?
I think it's a really great idea. I mean, I could easily characterize sort of my teaching style and and explain it to people and, what works for me. And I have had this experience where even with TAs where I say, oh, I've done this, I have computer labs for my staff for the life sciences. I say, I've done this, it's really fun, they love it. It'll take you a long time. And they say, well, we finished in 10 minutes, and they didn't seem excited. And it's a difference in teaching style. So something like that would be great. I mean, if there were a way to sort of categorize things and share experiences, it would be spectacular.
My first reaction is give Google another 2 or 3 years, and they'll have already characterized it all for us, and they'll say, "Oh, we know everything about you. This is how you should do it."
Enough time on a resource, then similar ones will be recommended.
Yeah.
So we've heard sort of different types of dissemination and getting people involved in learning about the resources. I mean, Gavin mentioned the workshops, particular Project Next, which I think many of us are probably familiar with this. I know colleagues who have participated in that. And it's very focused, self-selected. People have an interest in this, get together, learn something. And then what Laura is currently working on, the other type of dissemination, you produce materials and then hope somebody will come and use. Maybe want to spend some time on talking about sort of trade-offs between the two approaches and how effective each one of them is.
So it seems to me that to some degree they're complementary, and in fact better. They need to interact with each other. That if one is producing materials, then one wants to just sort of have a general mechanism to get them out, and then as part of the continuing process, then you hope that there will be some people who pick it up in workshops, or that there will be opportunities to present it to specific groups of individuals who would have specific interest in using them as well. And so I think that it's not so much of a trade-off as that there is some sort of complementary balance that you want to have. You need to have the project first, you have to have it out there, and then there has to be some other mechanism to disseminate it as well, or there ought to be some other mechanism, and the workshop format may then fit very well in that once you have the rest of the pieces in place.
Yeah, I should mention we do have some plans to try to do, once we have the modules put together, try to visit, starting with schools near to us, visit schools and sort of show them the modules and suggest how they might be used as part of a class and how they can be useful to people, and really hope that then sort of, you hear this worked well for us and this worked well for us. But we know definitely that just putting it up on the web and waiting for people to come is probably not going to be the best dissemination strategy. We're going to need to promote it and talk about it. So, but first we have to build it.
So I've been more involved in running workshops more recently, and what I have found out is that people may not use the exact workshop I developed, but then they use pieces out of this. For instance, I used Gapminder in one of the workshops, and then that's something people can take home with them and then introduce into their class. Or I taught pivot tables once with a data set, which there were primarily biology faculty in that group, and they really liked it as a data exploration tool. And so this reminds me of what Gavin said with the Project Next. Anecdotally, he thinks that people actually adopt what they learn in the workshop. So do they actually take what they learn directly, or is it that they take pieces out of this?
My guess is, as with any workshop, it's a lot of taking the pieces that they're going to be able to apply. And in some cases, it's going to be fairly large pieces, and in some cases, it's going to be much smaller. Another piece of which I think fits into the themes, the threads that we've had running through here, is this idea that one of the things that a workshop or something can do is, and to some degree even just online dissemination with blogs and comments can do, is create a community that then provides a resource to bounce ideas back through, which increases or enhances the likelihood that people will be able to use things effectively. And certainly the way I've adopted a lot of things was to try something, determine that it failed abysmally, and then find a group of people that I could get to tell me how to do it right. And then once I'd done that, then I was able to say, oh, okay, now it actually works beautifully. And somebody asks me, how do you teach? And I say, this is how I do it. It works wonderfully. And then I usually leave off the fact that the first time I tried it, it failed really horribly.
I agree completely. Community feedback on everything is crucial and very easy to get now that so many things are online, and it's very easy to communicate with people. And I think something we'd love in building these modules is if a bunch of people told us, hey, we really need a module about this. That would fit great in my class on X. And, we'd love to hear that. So I agree completely that getting feedback from the community and sort of adapting what we're developing to that, it would be great.
So essentially what we're asking for is getting more websites where you can socially interact with each other, but probably not in real time, because like if I teach this specific topic, there might not be anybody else teaching this topic, but then at least keeping the sort of a log going of questions people ask and hoping somebody will respond at some point.
Yeah, I think it's two-sided though, because there's a part of me that says the online communities are, for me, very much less effective than if I'm talking to somebody at a conference or if I'm sitting in a workshop and I'm able to ask questions. And so I think that the online communities have the potential to provide an outreach that we don't have otherwise. But I think that the other piece of this is that it has to be an effective communication medium that you can get the information relatively quickly. And this is sort of this contrast between leaving comments on blogs and doing email versus talking to somebody in person. The efficiency of the information transfer is much greater in the latter case, I think.
So we're starting to get some comments and questions from participating audience here. And so we get some question about they would like to comment on the barriers to dissemination. In particular, what this person mentions is that a push system like Webwork is fine to deliver content, but apparently to create this content people feel it's quite difficult, and so there are not a whole lot of learning management systems that are user-friendly, in particular for entering mathematical equations. Moodle has LaTeX in there. There's often no way of doing sort of hand-drawn like graphs or so in there. Do you want to comment on that? What you perceive are the barriers are, especially if you haven't so much with Webwork?
So my immediate reaction is I think that this is a very relevant point, which is that communicating mathematics is difficult online. I think that in the short run, it's likely that the quickest sort of workaround or solution is going to be the increasing integration of tablet technology and the ability to simply write stuff and have it show up as a scanned image or as a document. And I think that technology is going to